Let's start looking at the ingest tool, which takes data from the source database and puts it in the destination database. The source database, the changes are taken one by one, and then it ends up in the destination database. Taking changes from the source database makes it very fast. On the destination database, it doesn't just give you a hodgepodge of changes. It actually merges it back, and you get exactly the same table as you get on the source. There are other options how you want it on the destination database. We'll look at that soon. To set it up, the first thing we do is start setting up the connections. For the source database, I've used SQL Server, and I've entered all the details required for SQL Server. There's a number of other sources supported. You can have Oracle, you can have SQL Server, you can have SAP, MySQL, SAP HANA. You can also connect to Salesforce and almost any database that supports JDBC connections. Next thing is you specify the destination database. Here I've used S3 files and I merged them using EMR, and I've entered all the details required for that. Other destinations, you could have it in EMR but still load it into Redshift or Athena. You can load it to Redshift directly, bypassing S3 and EMR completely. You can load it to Snowflake. If you got a lot of data, lots of tables to get across, then you could use a multi-load version of Snowflake, which allows you to load multiple tables at once. That's the destination database. Then we come to credentials. Here we have used IAM access. It's probably the cleanest way to do it. If it's running on an EC2, it can use the EC2 profile to set up all its access. You can also supply it with AWS credentials instead, use the key secret key. Once we do that, we select the tables that we want to extract. We go to data. We see all the databases that are available on the source database. We expand that. We see all the schemas under there. Now let's say we expand on the schema called production. So the number of tables there, we selected product. That's one of the tables. The primary key is already selected. I'll set it to by primary key with history. If I select by primary key, you get an exact copy of the table. If I select primary key with history, not only do you get the table, you get every possible change that has happened in the table since Ingest started looking at it. So that gives you a great way of doing a point-in-time query. Allows you to do things like, what is the product situation on the 1st of September? How many times has the product number been changed for a particular product in the last 1 week? It allows you a whole bunch of point-in-time queries. Now we look at another table, which is work order. Now work order is a big table. And when you want to get it across, you don't want to get the whole table across in one chunk. What you do is, because it's a big table, we partition it. Now partitioning is pretty straightforward. You specify a partitioning folder. That specification there tells you what the partitioning folder looks like. It basically says take column number 6, which happens to be the start date, and put the year in. Year equals %Y, so it puts the year in, slash month equals %M, put some month in. So that creates a partition for each month. You could take it to a more finer grain situation. You could put the date in there. You could do it by quarter, by year, by half year. There's a number of options available, and that's just for dates. For numbers, you could have numbers in ranges, 1000 to 2000 in one partition, 2000 to 3000 in another partition. You can have it for characters. You can say, take the first character and make a partition for each character. So that allows you to handle fairly large tables. Once you selected all the data, you go to schedule and you say, how often do you want to run it? Here, what I've done is I said, okay, every 15 minutes, get all the changes from the source and merge it back on the destination. So while that's happening, let's look at some of the configuration variables, which can be of interest. On the destination database, if you got S3 EMR, you can say, I want it in this case, I've used Parquet Snappy compression. There's a whole bunch of other formats supported, bzip2, gzip, Parquet, orc. In addition, if you got an EMR instance which has got concurrency already set up, let's say I've got a big EMR instance and I can run 10 concurrent jobs, I can change the number of loading threads to 10 so that I take advantage of the 10 concurrent slots that I have on the EMR instance. So as that schedule runs, it takes all the changes across, merges it back on the destination, and soon you will have the entire table on a destination. If you said you wanted with history, You get full type 2 history, allowing you point in time queries. If you said you want it partitioned, it'll partition it for you. In this case, we have partitioned one table by year and month. So that's as far as ingest is concerned. It takes your data seamlessly across and gives it to you as a table on or a file in case of S3 EMR on the destination. Now that all the data has come across, let's go look at what it looks like in S3. We have all the tables that have come across. You can see they've got the database name, schema name, and the table name in there. Our special interest is work order. We said we want it partitioned. We click on that, we find out there is a partition which says year equals whatever. Click on it. Under that, there is a partition for each month. And within that month, you have additional folders containing the actual data. So that basically takes all the data across, puts it in nice partitions for you. If it is not partitioned, you probably will see that table as is. You can see that's got a file there. The format we're using is Snappy Parquet. Now we looked at all getting the data across using ingest. Now what happens if one of your tables is really big? Let's say terabytes of data are to be taken across. The initial extract is a big issue. That's where the next piece of software comes in. That is Excel ingest.